Welcome to the Homelab Show, episode 79, Virtualization versus Containers. How you doing, Jay?
I'm doing well. How are you?
Good, good, good. This has been a topic that it seems to come up a lot, and it's not like you have to go all one way or the other. And most
Right.
people end up with a hybrid approach, anyways, for what they have containered in terms of workloads and what they have virtualized in terms of workloads. We're going to talk about some of the pros and cons of this. And ultimately, it's not like one of these solutions will fit all of your needs no matter what. So you'll probably still end up with a mixed environment. But nonetheless, we'll talk about the pros and cons of them, some of our experiences, some of my confusion with them, which I don't get me wrong. I understand it from a very high level, but there are still some functional things that I get confused by that I think makes containerization certain challenges. But hey, we're going to talk through all those fun things here. Before we jump into the topic today, we're going to thank a sponsor of the show, and that is Linode. So if you're looking for a place to host many of the projects that we talk about on this channel, on this podcast, Linode's a great place to do that, especially because a lot of things, you may not want to run them in your lab. You may want them public facing or have some type of layer between you and your internal servers. So, hey, Linode's a great way to do that. Let it be on their public IPs and not your public IP. We have an offer code down below in the description for getting signed up with them. We thank Linode for the sponsor of the show. And if you want to sign up for them, use offer code the Homelab Show. Thanks again for Linode for sponsoring. All right.
Awesome.
Where do we start?
I think we can start by just giving a quick rundown of some of the basics, not spending too much time on this because I feel like, the majority of our audience will know these things already. Just trying to catch the few people out there that might be newcomers to Home Lab.
Yeah.
And if you're new, hello and welcome. Watch your wallet because that's going to be a problem. You're going to just run your. Okay, I'm going to not talk about the buying things problem because that's a whole nother story. But we're here to talk about containers versus virtual machines. So let's just talk about the basics. Virtual machines, containers at a very high level. What the heck are they? And we'll start there and work our way down the list of topics. So virtual machines are something that were just so magical when earlier in my career.
They're still magic.
They are, but it's just more. It's less so now because I think we take them for granted because when I started, if you wanted to spin up a new dedicated server, you would contact your server provider, order a server racket, and that server would then do that thing. And that server did only that thing. Well, hopefully some people would, have more than one thing going on, but that's another story. So later on, virtual machines came around and we could have more than one server sharing the hardware or basically running, on hypervisor that would allow us to have individual servers that think they're real servers on real hardware, but it's, just an abstraction all the same. But you have a boot process and you have all the things that you would normally have in a real physical piece of equipment. Even on some of these, you can access the BIOS right in the virtual machine and change things around. So that's more or less a software abstraction of a server, physical hardware, but turned virtual, hence virtual machine. And then when it gets to containers, the abstraction is much smaller because at that point, it's almost like Linux as a runtime is just one of the ways I could describe it. Although I want to be careful with that because it's not completely true. But if you think of a container as a blob of the file system that's sharing the kernel with the host operating system, you wouldn't be very far off because that's effectively what it is. We'll get into more information about that shortly, but it's much smaller, and you could run many more containers on the same piece of hardware than you could run virtual machines on that same piece of hardware.
Yeah.
So
It's just a lot
um,
lighter weight.
it's a lot lighter weight, and there's ways of sharing memory between virtual machines. I mean, one way that I like to describe the difference is that if you give a virtual machine 4 gigs of RAM, then it owns 4 gigs or 4 gigs of RAM. That's not completely true now because there's memory ballooning and some more advanced things to where memory can be shared between virtual machines. But just to keep it very simple, let's just pretend that's the case. You give a certain amount of RAM to your virtual machine, whereas with a container, it's more of a memory limit than it is dedicating memory to that container. You basically want to make sure, hey, container, you can't use more than, I don't know, 512 megabytes of memory. The memory footprint's smaller too, so you can get away with that. Nowadays, the smallest VPS instance on pretty much any cloud provider I'm aware of starts at like 1 gig of RAM. because the operating system is going to need some of that. But containers, they share the kernel, so they don't really need that have that same need. So at this point, most people might think, okay, containers are lighter weight, they need less RAM and all that. So why would I use anything else? Why would I want to waste hardware, waste RAM? That mindset is kind of true because you don't want to waste resources. But the next point I want to get to, which is another foundational point, more so an opinion on my end, but it's just based on experience, is, and it's more of a pet peeve actually, that a lot of people out there, it's almost like they learn how to use a hammer, everything's a nail. Let's container all the things, to the point where they force things that are not meant to run in containers or don't run in containers well to force them to run anyway. And they spend many more hours troubleshooting things just because the software wasn't meant to work that way, just to ensure that everything is in one tool, which I feel is the worst thing anybody can do, because basically we have different tools, different technologies that might fit one application better than another. I've seen applications that just don't run in containers because usually it'll come down to something the developer did wrong. That, I mean, they shouldn't be using like, direct paths to everything. Everything should be more dynamic. They don't always do a good job with that. So you could argue that if an application doesn't work well in a container, it's probably it could be the developer's fault. But either way, um, that's why we have all these tools. We have virtual machines, we have containers. You can run containers in a virtual machine even. So
Yeah.
you don't really have to separate them completely. But my main opinion is use whatever works best for whatever you're trying to achieve. However, when it comes to the smaller footprint of containers, sometimes you don't have a choice, because let's just say you have I don't know, I'm just going to make something up, a 4 GB Intel NUC. That's what you have. That's what you have access to. As much as we would love to buy new toys, we don't always have disposable income for that. If you have something like that, you could probably run a virtual machine on it, maybe two, if you if you really stretch it, depending on the size of the virtual machines. But when it comes to a container, though, well, you could have a lot more running on that smaller, on a lot less RAM. So in that case, pretty much you should probably just try to use containers whenever possible. Your hardware just isn't going to extend as far as it might on a dedicated server with more memory. Not that the NUC isn't a dedicated server, but I mean like an actual server chassis. So sometimes the hardware that you have available might just make the choice for you, in which case, well, that's all there is to it, right? We could end the episode right here for those individuals, but we're going to keep going for everyone else that doesn't have that limitation.
Right. Now, to kind of summarize things, with any virtualization, the hypervisor emulates an entire computer, for simplification. But the containers, and part of the reason Jay said that it has to have some compatibility and it has to be an application designed for it, is because whatever you're using for your containers, and we're talking more broadly, not about specifics like Docker, but we'll even go into the free BSD world, the containers share the kernel. This has some advantages. Those advantages are, of course, lightweight, because we're not trying to rebuild and emulate an entire hardware via an extraction through an hypervisor. The downside is, if the tools or the services that you want to run are not compatible with that particular kernel, they're not going to work well in there. Now, doesn't mean there's not workarounds and ways to get dependencies set up. This is one of the challenges with TrueNAS Core. When people ask about the jail system in it, and like, yeah, the jail system in it, which is IO cage, which is a form of containerization in BSD, it becomes a challenge if something was more natively designed to work in Linux. But if you grab these dependencies and put them in there, you can probably get this glued together and working. But there's, as software progresses, more and more things are offering a containerized install as part of their install process. Like, hey, we offer this as you can run it on bare metal. When anything you can run on bare metal is automatically, pretty much a guarantee it's going to work in a virtualized environment, any services, not necessarily things that need to interact with hardware. Then one more step further, going to containerization. Well, it's a pretty well documented, Docker being one of the more popular systems out there. So running any of those services, provided they have a Docker image, and of course, Docker Hub making those images available, which we will address today, is an interesting aspect, because Docker is not just containerization. It's also combined with Docker Hub and being able to just quickly pull images instead of building your own images. So they both
Yep.
have their merits and they both have their use cases.
Absolutely, and that's exactly it. You hit the nail right on the head, because it everything has its place. When you bring your car to a shop, the mechanic's not going to use the same wrench on every single part of your car and try to force that one tool to work everywhere. They're going to use whatever tool is the best fit for whatever it is they're replacing or working on. And when it comes to IT people, it should be the same. You could evaluate software in one. Maybe it works great there. Maybe it doesn't. You could try it in a container, see if it works better there. And just, I mean, ultimately just test it, right? And that way you kind of know. Now, there's one situation that is more enterprise. I'm going to not spend too much time on this because it's just an aside anyway. But sometimes the application developer doesn't support containers. Now, granted, I didn't say the application can't work in a container. I have seen applications that work plenty fine in the container, perfectly even. But then if the developer, there's some stigma, in some places because they're just not keeping up with the times, where they find out you're running their software in a container, then they're going to say, yeah, we're not going to support you. That's not supported. You need to install it on an actual operating system, not a container. Call us back once you've done that. We're not going to go any further. And I've seen that happen. Now, I'm not saying that I necessarily agree with that mindset. But then again, it's up to the vendor, whatever they support. But that's going to be more for the enterprise side of things. I mean, how many of us have support contracts for the stuff we run in Homelab? I'm going to guess not very many. I know some of you do, but I just don't think that's as common.
Yeah.
But I need to make that aware just in case you're taking this to work with you. Like you learn it at home, like a lot of us do, and then you take it to work with you. And then if you get a container working in your home lab, get it working at work, well, great. But if someone on your team calls for support, yeah, that's going to be a little awkward. So just keep in mind that can happen.
Right.
So the next thing is, talking a little bit about some of the individual technologies. So a lot of these we've covered like multiple times on the YouTube channels and in this podcast. You could listen to other episodes to get more of a background. But when it comes to virtualization software, the popular ones, obviously VirtualBox, if you're running it on your laptop or desktop. There's also a way to run VirtualBox as a headless server as well.
Yep.
If you're familiar with that, you can do
Oh, I
that.
did videos on that years ago.
Yep.
I
Yep.
haven't played with it in a while. There's actually, it might still be around. There's a tool called PHP VirtualBox to put a web interface on top of
Yep.
headless VirtualBox.
Yeah, I think I can't remember the name of the one that I've tried out, but they exist. So I mean, ultimately, VirtualBox is more for, on your laptop or desktop to evaluate software and test things out. Developers use it like crazy, but yeah, you could also use it as a headless server. There's nothing wrong with that. XCP-ng, which you cover a lot on your channel, and we've talked
Mhm.
about here. Proxmox, which is what I use, and as another aside, I like them both. A lot of people are team Proxmox or team XCP-ng. I like them both, honestly. Like, I mean, I wouldn't be very put off if I was using XCP-ng instead of what I have, which is Proxmox. However, I think the ability to spin up containers in Proxmox by default is just the tiebreaker for me. But they're both
Oh,
great pieces of
yeah.
software.
No, that's a great feature that they have on there.
Yep.
There's no good in you can find some old history. It's just never been well developed and it's kind of left stagnant in XCP-ng for container management. People ask me about it from time to time. They'll find some old documentations about Zen and managing containers. It's old documentation and no one's actively, that I'm aware of at least, developing that anymore. So if you want that mixed environment of, is it LXC containers in Proxmox? Is that correct?
Yep. Yep,
Yeah.
and it's weird, it's pronounced Lexi, but I might say LXC as well out of habit because before I heard it spoken, I've always said it that way. Yeah, but that is correct.
Yeah, so there's it's if you want that mixed use case, it's definitely Proxmox is solid for that.
Yep. And let's talk about some of the container technologies at a high level. Now, there was a comment in the chat room. I think it might have already scrolled by. Somebody mentioned snap packages, and I just want to touch on that real quick because there's the concept of universal apps in Linux. They are not containers, but I completely understand. And I'm not saying anyone in the chat room thought they were containers. That's not what I mean. I mean, someone just said snap package, and it reminded me. So some people might think they're containers. Now, they're container-like in the sense that they have like the entire paths and all the dependencies and everything built in. They're essentially a a way to install applications on Linux workstations and servers where you install one thing, has all the dependencies built in. And it's more for helping application management than it is for the things that Docker or other container solutions would help you solve. But I just wanted to throw that out there. They're not the same. There's overlap, yes, but they're not quite the same. Now, moving on from there, let's talk about the actual container technologies. Now, Docker is going to be the most common, and it's kind of like, at least here in the United States, we'll say, if we're not feeling well, I'm going to go grab a Kleenex. But it's not a Kleenex brand. Kleenex is the brand, is a tissue, but we call it the same thing. Whereas a container, it's almost like Docker becomes a term, and sometimes it's used incorrectly. And I think I even use it incorrectly as well, where I'm just going to run a Docker container, then they spin up a Lexi container because they, you know, think it's one and the same, or they don't necessarily think that, but it's just how the word or the verbiage works. But Docker itself uses containerd as the runtime. The runtime is what makes the container happen, what runs it effectively. Docker is a way to manage containers. Now, they used to be one and the same. There was a split. That's a long story. But nowadays, the recommended approach, if you want to run Docker containers, and there I go using that term, you're going to install something like containerd, a container runtime, to run that container. So just wanted to get that out of the way. Now, Docker containers are absolutely the most popular. Like I mentioned a few minutes ago, they're not the first. I know Lexi containers were earlier. Linux containers is what that stands for, if anyone was curious. So Linux containers were there. Docker just had like a much bigger marketing kind of thing, and it's like you put a term on something, and something that already existed for a long time all of a sudden becomes super popular. And what a container is basically an abstraction of an application from the rest of the operating system. And there's going to be, and the term is right there, and I'm trying to make it come out. C groups, there it is. So using C groups, it helps isolate the process from the rest of the system. And that's one of the great things about containers, is because they're isolated from the rest of the system. Virtual machines are as well. And as long as no one finds a CVE that allows an escape of a sandbox, then yeah, the application is completely contained. So we touched on Docker containers, and you also mentioned as well there's the Docker Hub and all these things that are wrapped around it, which is pretty cool because if you want to run Docker containers, then you'll have easy access to any container you could probably think of. You want to run a container based on Ubuntu, go ahead. Nginx, fine, no problem. On the Docker Hub, you'll find no shortage of containers that you can run. But how does that differ from LexC? So when we get to LexC, the concept of containers seems a lot different because with Docker, there's layers, right? So if you have let's just say you download an Ubuntu container and then you install Nginx. When you install Nginx, that becomes another layer. And then if you do apt dist upgrade and pull in all the updates, that's another layer. So every change you make is like a stacking layer. Lexi containers are not like that. They're more like virtual machines. And that's one of the things I like about them because the networking is easier to figure out on Lexi containers because you can actually set it up to get an IP address from your DCP server. It could present a MAC address to your pfSense, OpenSense, whatever it is on the other end that provides IP addresses for your network. It could grab one and you can communicate with it over the network just like you can anything else. I'm not saying you can't do that with Docker, but it's more or less built in with Lexi. With Docker, you need to put a load balancer in front of it if you're not accessing it localhost, for example. But I would say Lexi containers are more of a virtual machine approach to containers. You get a lot of the strengths of having a virtual machine. You can log into a Lexi container. So if you access it, you get a login prompt, you log in, and then you're using it just like you would a Linux instance that was dedicated. So I really like that a lot about it because I could just expose it right to the firewall, get an IP address, and there you go. And I could send traffic to it, no problem. Port forwarding, no problem. But Docker, again, you could do those things, but you're going to have a little bit of a little bit more work to do to set that up. And there's going to be some turnkey solutions that'll help you with that I won't get into. Now, another technology that I have not used, but I've been wanting to try this out, so I just felt like I needed to mention this. It hit my radar a couple of years ago, and I still haven't had a chance to look into it yet. It's called Kata containers. That's what the technology is called. And my understanding, again, I've not used it, but just from the marketing speak alone, what I gleaned from this is that it's a container technology that can utilize the virtual machine extensions of the host hardware. Now, that's a big difference between containers and virtual machines in general, because virtual machines are going to need that virtualization support in the CPU in order to work. A container is not going to require that. But Kata containers can hook into that, so you can get some additional acceleration capabilities there that you might not be able to get otherwise. Maybe that might make the difference for you. Maybe you have an application that you want to run in a container. You've tried it, doesn't work very well, but then you find out maybe all it is it just needs a little bit more horsepower or something. And of course, I'm making up a use case because again, I haven't used it, but I just want to make sure that people are aware that it exists. And if anyone has a chance to try it out, I would like to hear what they have to say about that.
Now, one of the big disadvantages, and I've seen someone comment on this, and this is where I have struggled sometimes when setting up things in containers. The networking is a lot different. And
Right.
it's not something impossible to solve. And I've obviously seen and know large companies doing very large scale, wonderful, amazingly stable deployments with these and have it all sorted out. But from coming from a holistic system that's either virtualized or if it's a um, just a simple virtual install. I know where my networking is. I understand how whichever hypervisor I'm using, I understand how it handles networking in a very clear way. And because I'm just, emulating a machine, I can treat it accordingly. Once you start tying all the networking together with the images and the different container tools, that can be a little bit more confusing. And then
Right.
that can be compounded by the different deployment methods. And I actually have directly commented this on the TrueNAS deployments that they've done with Scale, where even if you check the box, which would make sense that it's supposed to do host networking, I believe it's called host Mac VLAN networking in the Docker system they're using. I think I used the right term there, but essentially I want to give that image its own network space and have its own IP address. That doesn't always work consistently, and there can be
Right.
some challenges in getting that set up. And if you're going upstream further and you're using some type of external firewall such as pfSense to manage that, it can be a little bit more confusing when you want to manage things or do policy routing based on IP. So there's extra complexities. Now, these are not unsolvable or intractable problems and reasons not to do it. It's a different learning curve if you're coming from the old school world that Tom has been in for a long time before all this technology existed.
Right, right. And some of these containers will solve a really awesome use case that is not unsolvable by other means, but are just such a great fit. So one really good example of this is, and this is going to impact a lot of you guys listening, we buy off lease server hardware quite commonly, and sometimes you'll have like the iDRAC card that requires Java. So that should mean that you should probably install Java right in your browser and make sure. No, don't ever do that. Don't ever put Java in your browser. Bad idea. So this container that exists, I forgot the name of it, basically contains Java and everything that's needed for you to utilize your iDRAC card before iDRAC switched to HTML5, because later versions, as we've discussed before, they don't have a Java requirement. But if you're stuck with a server, I shouldn't say stuck, but if your server has an older iDRAC card that cannot be upgraded, then you could use this container to access the iDRAC card without installing Java on the host machine and then adopting all the security vulnerabilities. Because the slogan of Java is write once, exploit everywhere, right? I
Right.
think it was something like that.
Yeah.
But that's a great use case for a container, and that's a great value that someone made that available for people that are in a similar situation. They saw an issue, they solved the problem, they made it available for other people, and that's a good use case for it. So I just wanted to mention that exists. Now, now to your point about host networking, you're gonna really love Lexi containers, man. Let me tell you, because it's absolutely the virtualization approach to that. Now, in the example of the iDRAC container that's running on your local computer, at that point, it doesn't matter. It doesn't matter about the networking, or I mean, it does, but it doesn't because it's running localhost. And some people will install containers on their laptop or desktop just to run an app localhost. And even though it's solving a different problem than like Snap packages, some people will actually use it as a universal app. Nothing wrong with that. If that works for you, that's awesome. But when you have a dedicated server that's running your containers, that's when the host networking comes into play, and you have to figure that out, which could be a load balancer in front of it. Maybe you'll use something like traffic in front of it. There's different solutions for this. There's built-in solutions as well, but I feel like there's a reason why there's all these third-party solutions for networking for Docker containers, because they just do it better. They just do. Um, and one concept we're not going to get into today is container orchestration, which also solves the networking side of things. That's when you have something managing your containers for you. And an obvious example there is Kubernetes. That's the most common one that anyone will run. And that'll help you orchestrate your containers, basically make sure a container is running. A certain number of containers are available out of a certain number of maximum if you want scaling or things like that. There's other resources, and that's a whole nother episode. So, yeah, go ahead, Tom.
I was going to say there's also Portainer. We'll throw that out there.
Yep.
We're aware it exists. There's other people have done some videos on there. Our friend Christian Lempa, That Digital Life, he's done some videos on it as well. I believe Techno Tim has a few videos on it. So that's it's a great tool. I've actually been playing around with it. I like it. It kind of makes your Docker system a little bit more manageable through a nice web UI.
Yep. So now with all that high level explanation out of the way, let's just double down on the topic, to container or not to container. That is the question, right? And I've already touched on some of these. If the application doesn't run in a container, and sometimes the only way you can know that is by just giving it a try, then run it in a VM. You shouldn't force something to run where it doesn't, run well by default, just by nature of how it's designed. I mean, I'm not saying you can't get an application not meant to run in a container to run into a container, because if I tell anyone in the audience you can't do something, they'll do it and they'll let us know. So we're well aware of that. But the question is not can you run it in a container at that point, is more or less should you? Because let's just say you get it working later on down the line. There's an update to the application. Now, whatever workaround you're using doesn't work. You have to find another one. There could be some weird issues with the application that might not be otherwise explainable. And that's where we get into the whole point where you shouldn't force something to run where it doesn't run. I would hope that every application could run and be more dynamic, but the world we live in is not that world. So that's the first consideration. Actually, the second consideration. The first is your hardware. If you don't have very much in the way of RAM, you don't have a choice anyway. It doesn't matter. Like anything I'm about to tell you, just goes out the window. It doesn't matter anymore. So that being said, so getting the hardware side out of the way, let's just assume you have an application that runs great in a container and it runs great in a virtual machine. Well, in that case, just throw it in a container, because you're just going to have a smaller footprint. Just makes more sense. Otherwise, unless you have like so much disposable RAM that you just don't care, which is probably not most of you, then I would throw it into a container as the default if there's no other reason why it should be in one or the other. So that's one consideration. Another one is like web apps. Let's just say you want to, I don't know, show an Apache web page. There's very few circumstances I could think of where that would not work in a container. That's a great use for a container, a website, a blog, or even just a static HTML page. Container all day long, because that's just going to be the best fit for it. If anyone knows of a use case where that doesn't work, let me know. But if you're just running like Nginx or Apache and trying to serve something, well, you know what? It's probably a container at that point. I think that makes the most sense. The other side of this too is you might have an application that runs only in Windows. I mean, that happens, right? So often we'll have a Windows VM and we'll run that app in there. Well, you're not going to virtualize Windows. Can you find a way to do it? Containerize Windows, I meant to say. Can you containerize Windows? No. Can you? Is someone in our audience going to find a way? Probably. So again, I have to be careful how I talk, because somebody somewhere knows how to do it, but I'm speaking more in a general sense. So if you have like an operating system and you want the full operating system experience, maybe you want to run Mac OS in a virtual machine. I've seen people do it. Windows, obviously. That's going to be a virtual machine, because when you run containers, it's implying Linux at that point. And so, like I said earlier, it's almost like Linux as a runtime. Again, that's not completely correct. That's an gross simplification of it. But that's just going to be the way that is. If you have an application that runs in Linux, then it's going to be the most probable thing to get working in a container. But if you want the full Windows experience, it's going to be Windows. If the application requires something at the OS level to be emulated, and I've seen this happen, then that application must be run in a VM. Otherwise, it's just going to throw errors all day long if you try to throw it in a container. The downside is sometimes it's just trial and error to know. Maybe you might not be aware that an application will work in a container until you try it. That's part of the fun of Homelab. It's also part of the frustration as well. I would love to give you a formula for this in particular, but sometimes it takes just giving it a try, and then see how well it works or how well it doesn't. And sometimes that will determine your next step.
Absolutely. And someone pointed out, and this is another good point, though, if you need to manage kernel level things, it's not an impossible task, but it's probably it can be more problematic. If you need kernel space for NF tables, IP tables, kernel modules, etc.,
Yep.
there's probably a way to containerize it, but you are now getting things a little bit even more convoluted. And maybe that if an application has to run that, there's that I know of, and doesn't mean someone won't invent it in the future or someone already has done it,
Yep.
firewalls that run in containers. That would be like, can we just build our own firewall running it in a container to help manipulate all the other stuff? I mean, in some ways, Portainer, because it has access to managing things, might
Yep.
do something like that because you're using it to control the networking of the other images you have. But yeah, that can get you got to think about that too because of the you want clear privilege separation for security reasons. So you have to really make sure you understand what any of the privilege cross the other containers might be and where there may be a risk inside of there.
Yep. And it was early in my Homelab experience where I ran no virtual machines at all, zero, because the hardware that I had was 4 gigs of RAM, and I just didn't want to, just try to force virtual machines to run in that. I could have. I had, like, somewhere between 4 and 6 different things I needed to run, so it was like C containers, that's what I used, and it's funny because I remember it was a Black Friday deal, which I normally don't go for, but Dell was selling some servers, brand new servers, never before used, and they were like some ridiculous price. I think less than $200 brand new or something like that. I'm like, yeah, I'll buy one. And they came with 4 gigs of RAM, and I figured I'll just upgrade the RAM. And found out later the RAM was like extremely expensive for that server. So I just stuck with the 4 gigs for a while until I had a dedicated server of my own to build my what's now my Proxmox installation. So everything had to be a container because running a virtual machine was just going to be a problem. And I didn't run and this is kind of like the point I was trying to make. I didn't have any piece of software orchestrating these or anything. It was simply Ubuntu server with LexC installed. Well, actually LexD with Ubuntu server because, well, I'll talk about that in a minute. But effectively, LexC containers just run by the command line. I didn't have any web interface or anything. That's just how I did it. If I wanted to start or stop a container, just SSH in, start or stop the container. And I didn't really feel I needed a web interface. I still don't, but it worked for me. And then later on, I had some things I wanted to run in virtual machines. So, I went that direction. Now, I did mention LexD, so I feel like I need to talk a little bit about what that is. LexD is a layer on top of LexC that is primarily developed by Canonical, aka Ubuntu. Um, LexD could be run elsewhere as well. So just because it's Ubuntu doesn't mean it's only Ubuntu or developed there, doesn't mean it's only available there, but it gives you some additional functionality on top of LexC, like central storage. It can hook into ZFS. I'm pretty sure Btrfs, if I remember correctly. So it's almost like LexC plus plus. It gives you, and you even use the LexC command set to administer this, even though it's LexD, which is why it confuses people. But I actually like that a lot, and that's actually what I was using on that server was LexD because I actually wanted some of those features that it provides, which I thought adds a lot of value to LexC. LexC itself being the virtual machine equivalent of containers, plus the LexD features almost makes it seem like a complete virtual machine orchestration solution, but it's containers, which is really cool. And one of the reasons why I like it so much. So that's what I was running at that time. So, and that's LexD, yet another technology. It's like an alphabet soup of various different technologies that people can choose from when it comes to these types of things.
Absolutely. So much.
There's so much to talk about, because it's like we define the things a little bit here, and yeah, it's more high level, and we can always go deeper into anything that we talked about in a future episode. Anything that we mentioned is fair game here. But at the end of the day, what I really want to get people away from, and someone in the chat room, brought or said it better than me. Some people try to pound a square peg into a circle shaped hole or something just because they're trying to force it to fit where it doesn't. As long as we don't use that mindset, and I've seen this mindset on cloud. People will say, like companies especially, everything needs to be in the cloud. I read that in a white paper, and the white paper never lies. So since the white paper says it needs to be in the cloud, we need to move every server in the cloud. Next thing you know, they moved their NAS and everything into the cloud, and then they have like a $20,000 a month storage bill. Congratulations. That probably wasn't a good idea. But wherever technology fits, that's where we should use it. And that was some high level information about where some of these things fit.
Yeah, and I think what Oliver Lambert said, and if you're not familiar with that name, I've tweeted out many things that he said because he's the head of the Vates team that develops XCP-ng. And he says that's why containers should be seen only as a way to package and never isolate tools. And it's
Right.
reference to some of the comments about people saying, security and things like that around them. Yes, it's a great way. And the containerization has really helped push forward a lot of large scale web application deployments. A lot of companies have to build things on the resources they have. And if they were to run a virtual machine for everything, that would be kind of cloud heavy, if you will. But by having a virtual machine that you're running, and hey, you can run that in XCP-ng and then have each of those virtual machines and a whole list of applications that build a series of essentially microservices that are all running and contained within there. So you can switch them out from a deployment and control level. It's just a way of thinking of how all these tools stack together. At the end of the day, there may be a virtual machine running all these, and then your containers live inside that virtual machine where you have a whole ton of little applications running in these containers to make the most efficient use of that. And then, of course, they can coordinate with other nodes that are maybe geographically separate, and you can scale this out to a giant enterprise deployment. So quite a bit there. You're on mute, Jay.
That mute button. So elusive. Okay, so I think we should probably bring up something that, like, I almost forgot to bring this up. We promised we would talk about this. We got to talk about that Docker Hub because that
Oh,
is
yes.
a big deal. And I know this is probably going to be the most controversial side of it, but we're coming with experience and we pay attention to the industry. And anyone that says, well, there's no problem because I've never had a problem. Right. Nobody has a problem until they do. So that comment never really helps because um, we need to report on the fact that something can happen, and that is supply chain attacks. Now, before we get to that, Docker Hub, I do want to say it is amazing though, because there's like countless, and I forget how many container images are available there that you could use to create your containers with. And the idea is if you wanted to run an Nginx container, why install Nginx manually when there's an Nginx container you could pull down? It's already set up, and that could be a layer in your chain. That's valid. That makes sense. But supply chain attacks are very common. They happen. We see them in open source. There's reports of poisoned Docker images on Docker Hub. And I'm not saying this to throw Docker Hub under the bus and tell everyone not to use it, but just to keep your eyes on this, because if you didn't build the container yourself manually, then you don't know what's in it. And my opinion is, whenever possible, you should always build your own images. Never use Docker Hub or anywhere else. Just use your own. I know that's going to anger a lot of people, but that is my opinion. That being said, I do understand there is a use case for the Docker Hub. And if you have tools and things that scan it and you're on top of things, there's no reason not to use that. But when you manually build things, you know everything that's there, what version it is. There's no mystery things in there. You've built your own image. That's always going to be better. But sometimes you don't have time for that. You have like 2 weeks to get something deployed, and you have to get it done as fast as possible. Your boss said so. Doesn't matter what Tom and Jay says. You have to do what you have to do, and I totally understand that. But these types of things do happen, and we need to be mindful of that because we shouldn't just trust every container that's in the Docker Hub. If you're going to use an image, you should be looking into there and find out what's in there, or better yet, just build your own. I feel like for Homelab, we like to build our own stuff anyway, for the most part. So I don't think that's going to
Yeah,
anger
I,
too many people. But I do understand a lot of people are very vocal. But again, we come at you from industry experience.
Well, and I come at it from the supply chain and thinking a lot
Yeah.
about, and this is where things are ramping up, is supply chain attacks. And someone said I was fear mongering when I had posted a bleeping computer article, and probably they exaggerated things at some point to get you excited. 1,600 Docker containers found with some type of malware, or some number like that. And
Right.
If you said, "Hey, percentage-wise, Tom, that's extremely small percentage," and I would say, "You're right." But the reality is it depends on what container it is, and I'll throw Unify out there. One of the questions I had, because people wanted to know why I wasn't recommending running Unify in Docker, and I'm like, "Well, I don't think it's maintained by Unify," and then I looked and confirmed it was maintained by some individual. Awesome that that individual was maintaining it. And it doesn't matter if there's, a quantity or only a small percentage of Docker containers that had some type of malware they found. It's probably going to be, and it's the same thing that goes for things like Android apps. It's going to be in the popular ones. That's where they usually target. Can I get it in a popular app that there's also not direct support for? And Ubiquity is an easy example of this. People really like Unify. It's a really popular product. They don't have, that I'm aware of, still a way to deploy it via Docker in terms of like from them officially. There's no officially supported way to do it. Doesn't mean it can't be done. It's actually an app that works fine in Docker, as people have proven. But if you're not the one building it and you're just pulling someone else's Docker image, well, how well do you know that someone? Now, if you know that
Right.
someone, you reached out to him, you say, I trust this person, then that's fine. And that's what each one of these should be vetted with. I use Docker when I pull from official sources. For example, Bitwarden. That's how they do their application delivery. That's fine. It's from Bitwarden. It's not from someone who decided to start up a hobby project of maintaining it. And it's fine if someone does, until that person gets an offer they can't refuse, or just doesn't maintain it very well, and someone else just picks it up later because they give it away to someone. You always have to think about where those images come from, and that's just good supply chain. Now, we already have our own challenges in the supply chain of, what if someone takes over this NPM or Python library? Those are challenges that exist anyways. They're only compounded by the Docker problem that I had posted about with Blapey Computer.
Right.
And you can just Google, compromised Docker images. And, this is just one of those things that is really should be, I should say, uh, in people's minds. Where did I get it? Because so many tutorials, because they want to do it with the briefest way possible. They're like, hey, here's how to get started with insert name of something, and Docker pull this random person's Docker image and throw it into your stack. All right, now here's how we get the rest of it done. Think about that in a very concise way before you rely on something that's built that way.
Another aside too, and you mentioned this, but just to expand on this, sometimes someone getting a better offer, moving on, or unfortunately, some people get burned out or whatever the issue is, and they're not maintaining that anymore. It means that you can have a container that has no, that no one got into and put poison in, so to speak. So there's no supply chain attack going on. It could just be something that is just sitting there unupdated. And unless you're checking this regularly, then you might just bring in a CVE just on account of the software in the container not being updated, or something in the container not being updated. But to be fair, that same thing is true for PPAs on Ubuntu, for example, Debian repositories, or any software repository, regardless of what it is. For example, recently, I think it was yesterday, there's an SSHFS video that hit on the channel that I uploaded. And in that video, I'm telling people, be careful using this because it's not maintained right now. I'm hoping that it becomes maintained, but it lost its maintainer, and that's a very huge technology there. So you shouldn't be using SSHFS to transfer anything that's confidential, because again, it's not being maintained. And I found that out by going to look at the GitHub page, and if I didn't do that, I would not have known. I might still be recommending that on the YouTube channel, but we have to check these different things. So it's not specific to the Docker Hub. All repositories have this issue, but you just have to be mindful of that. If it works and it has no security concerns, great. Just make sure it's maintained. But
Yeah.
ultimately, just know where you're getting your software from, and just don't, freely accept any container image that comes your way any more than you would just, run a, curl pipe to sudo bash command one liner on a website without checking the script first, right? Just make sure you're checking things out and be responsible. And I think you'll probably be fine.
Yeah. In because it was in the comments here, I'll bring it up because there's people offering, and I have a video where I use a GitHub script because I have talked to the developer of this particular script that has a script that installs Zen Orchestra. But then there's also people who have Docker images of it. But I've also built Zen Orchestra for using the full detailed instructions from the official people doing it, and that's going to be your best way, unless you take the time to understand the GitHub script or take the time to understand the Docker images, because you want to know what's in there. And
Right.
ultimately, it's just one of those things you really need to consider and think about. And it's fun for testing. I mean, if you just want to build something and it's a lab, hey, cool, this Docker image. If you're going to run something in production, really take your time to vet it. And of course, you have the official for anything. Look for the official way to get the packages. And in the case of XCPNG, there's an official way to get these in Orchestra Appliance with a full delivery method from the official people. It's just one of those things you really have to think about before you put things into production.
And sometimes these containers just, again, there's just so many clever use cases. I just want to make sure I'm clear
Yeah,
on that. So we're not anti-container, but
no,
one thing
we're
I
pro security.
remember,
That's
we're pro security. I remember a friend of mine, and this was so long ago. I wish I had this Docker file still to this day, but he developed the first version of this, and we kind of worked on this together. It was just an internal thing, but he literally built a Docker container image that had Wine, Linux Steam, and Windows Steam running through Wine in the container. And it was like the ultimate Linux container or gaming container, because if an app wouldn't work on Linux native, or a game wouldn't work on Linux natively, then it would just be, you just bring up the Windows Steam through Wine, and most of the time that would work. Or native games through Linux was great too. But it was very complicated because you have to expose the video card and hook into that. It took a while, but it was so cool. But anyway, at the time we had a container image we could just pull down and then start downloading games and play them. So I remember going over to his desk and seeing Skyrim running back before I knew that was easier to get working on Linux. Oh my God, like, how'd you get that going? And there's so many different cool use cases like that I feel like containers just really created this renaissance of, we separate applications from the host OS, which is great, but then people take it further, and then they abstract gaming even through a container, which is just crazy. But that's just how smart Homelab people are.
yeah, fun stuff.
Very fun.
I think we've covered all the topics here. I'm looking at some of the comments to see if we missed
Um,
anything, but
we did miss something. We missed that email address.
oh, email address feedback 2022 at the Home Lab Show. We created the email address with your trouble setting it up, and then we've been forgetting to mention it. So
Yep.
that's an easier way to get feedback to us. We're going to start mentioning it at the beginning of the show next time. So that's
Yep. Yeah, maybe
that
we'll
way
get more
people don't have
feedback
to wait
that
till
way.
the end to hear it. But yeah, we do want to hear from you. We want to make it easy. We like doing the feedback shows, and we like the thoughts and ideas that come from the Home Lab people here that follow us, and different things they want to cover, different topics they want us to expand on is always a lot of fun. We love engaging with the audience because, hey, we're here to preach some education, talk about security and some better ways of doing things, and
Yep.
raise all of us up to be better people and better
Absolutely.
technicians on all this. I can't really help
There
if
you
you're
go.
not a good person or not, but I can at least try to make you a better technician.
Better tech person, I guess.
Better tech person. That's always our goal. Well, thank you for joining us. This was a lot of fun. Jay's got a brand new Bash series. I can't help but plug it because
I should have plugged that. Why didn't I plug that?
it's
I
plugged.
forgot.
It's great. I mean, it's free. You just go watch it on his channel,
Yep.
Bash scripting series. And when my employees even just started watching it, I started watching it. I'm like, okay, I need to brush up because boy, I had forgotten a couple commands, and it's a good refresher course. And it's at no charge to you. That's the Cyber Monday deal. We're giving it away. we don't have a sale. Jay's just giving it away for Cyber Monday. But that all got
Give it
released
away, and it's
the
going
other
to
day.
be free forever. It's not like this week and I'm taking it down. It's just
Yep.
there, and it's going to stay there. A quick, I mean, there will be links in the show notes, but a very quick way to get to it is if you type linux.video/bash1, bash2, bash3, it takes you right to that episode.
Yep.
And it's super easy. Linux.video/bash and then a number, and then that'll take you to the episode number. So you can start at bash1, and then if you hit bash 1, the playlist will keep you going through the rest. But that's kind of like the system I have set up, so you can get to it pretty easily.
It's linux.video, right?
Yep, linux.video/bash1, and then so on through the rest.
Perfect.
So
All
not
right, I'll
0,
put that in
1,
the
just
show
1.
notes. All right. Take care, everyone. Thanks.